Hey, what's going on, everyone? This is Mitch. Good Thursday evening to you all. I hope you guys are doing well out there tonight and had yourselves a wonderful day. And I certainly hope everyone has been having a great week out there so far to draw a little bit closer to that weekend. I don't know about you guys, but I am certainly ready for the weekend. But here to give you an update on the tropics. There's a lot of chatter out there about the potential for a hurricane in the Gulf of Mexico. And I would say some of that chatter is certainly warranted. And that's what we're here to talk about. We're going to go over all the latest model guidance for this area of interest in the Western Caribbean. I will say nothing is there right now. Nothing is formed. We don't have any kind of named storm in the Caribbean right at this moment. But the reason we are talking about this so much, and I only can speak for myself, but the reason we're going to talk this to death is because the signal on all model guidance is very loud. All models just about are showing something. This isn't like we have just one random model run that's showing a catastrophic category 4 or 5 hurricane. No, all model guidance is showing something eventually organizing and getting into the Gulf of Mexico and developing into, worst case scenario, a major hurricane, and some of it's just a tropical storm. But man, there's a lot of information to go over. So we're going to continue to pump out the information on this. We're going to make 2 videos a day because I think it's important to, 1, come back and get new, fresh information, and then 2, and honestly, more importantly, I think it's important to continue to go over this information, especially the portions of these videos that we talk about on like the environment that drives strengthening and the steering currents on what steers these systems, kind of like the portion of the video where I nerd out with you guys and draw on the screen. I think it's important to continue to go over all that for people who maybe don't understand it the first 1 or 2 or 3 or 5 times they watch it. And then all of a sudden it clicks, because I think it's very, very important for the public to not just jump on here and look at these fancy model runs and then head on out. It's important, and I know some people don't give a darn about it. It's important to understand what drives all this in the weather world, because there's so much more to it than just the surface, right? So if you guys have not subscribed, certainly consider doing that. Like the video if you like it. And if anybody has anything that I can pray about or pray over, as always, please put it in the comments below so I can do that and so others have an opportunity to do so too. So let's get rocking and rolling tonight. So let's make sure this is going to work. We're going to use blue. It is. So Gulf of Mexico, Caribbean, Southwest Atlantic. I just want to check all that off the box here. This is the area we are going to watch over the next several days. There's nothing going on right now, but this is the area we want to watch for any kind of energy to consolidate, eventually come together, and then drift into the Gulf of Mexico. Heck, it might go over the Yucatan Peninsula, get over the Bay of Campeche, or it might go right over Cuba and head right towards Florida. But regardless, another reason why we are talking about this so much is because, listen, let's be real. Anything that typically gets in the Gulf of Mexico eventually hits somebody, whether it's just tropical moisture or a Category 5 hurricane. I mean, it's not like something is going to develop, head into here, and then pull a loop-de-loop and then head right back into the Caribbean, and then, just go on out, back out into the Atlantic Ocean. Okay, that doesn't happen. All right, so this is a legitimate concern. Is it anything to freak out about? Absolutely not. But what's driving this is you see all these colors down here, like the yellows, the reds, blacks, etc. This is just one huge area of low pressure. It's called a CAG. CAG stands for Central American Gyrome. It's basically this huge, broad area of low pressure that quite literally just kind of spins down here. Okay, it just spins cyclonically, and it's not really a great example of this because this isn't really full-fledged spinning, but you might actually see that over the next few days. But sometimes with these setups, energy can drift on this side or this side. So the Atlantic side, and this is the Pacific side, and eventually it can consolidate into energy, whether it's right here, maybe on the Pacific side. So we're watching this area right here. So I just want to get that, explain what's going on here, where this is going to come from, and all that good stuff. So the latest from the National Hurricane Center. Now, this is pretty much the 2 p.m. update. We're going to ignore those 2 areas of interest out here in the Atlantic. I'm not talking about those right now. Might be something to talk about here in the future. As of around the 2 p.m. update, this area we are watching has a 40% chance to develop sometime over the next 7 days. Now, when I say develop, I mean develop into a depression or a named storm. And by the way, remember that system off the coast of the Carolinas that delivered over a foot of rain to areas in southeast North Carolina did not take the name Helene. So we still have Helene in the list of names for this hurricane season. The next name is Isaac. We could take both of them around the same time in a very short time frame. So I'm not ready to call this Helene down here if it forms, or Isaac, but it could be one or the other. So just keep that in mind. So we're not going to use names right now because I don't want to confuse the mess out of anybody, all right? The next update comes out, let me look at my phone, comes out literally in about an hour. I would not be surprised if they bump this from a 40 to a 50% chance, but it doesn't change anything that I'm going to explain in this video, okay? Now let's go over the latest GFS first. And in fact, we're going to go over the GFS from 12Z, and there's a reason I'm doing that. And then we're going to look at the 18Z GFS model run, which is literally running right now, but it should be all the way through enough for us to actually see, I would say, the best portion of it, which is the potential for this tropical system. And I say best portion, that's not Mitch wanting a tropical system to hit land. What I mean is we should be enough through the run to see the stuff that we really want to see here, okay? So let's look at the 12Z GFS. We're going to start all this off for Sunday evening, September the 22nd, right? Look down here, just a blob of green, some splotches of yellow, red. Just consider that tropical moisture, okay? We start to get into Tuesday morning. Pops off a low pressure here, but don't focus too much on that. We get into Wednesday morning. It looks like we're starting to just get this massive area of moisture down here. So let's use pink, okay? So we got this huge spin down here. I mean, this thing can quite literally be spinning this broad. So, I mean, the spin could be ongoing all the way through the Bay of Campeche, all the way through Central America, the Western Caribbean, all the way into the southern portion of the Gulf of Mexico. This is huge spin. Okay, when does it consolidate and form into a organized tropical system? Well, it does already have a 997 millibar low Wednesday morning, the 25th. Now we get into Thursday morning. All of a sudden we have a 993, and this is finally getting into the Gulf of Mexico. We get into Friday morning. Let's check this out. From Thursday morning to Friday morning, this literally spins in the same spot just north of the Yucatan Peninsula for 24 hours. And check it out. From Friday morning to 27th, not tomorrow morning, Friday morning to Saturday morning, it starts after, look at this, after going northwest, it stops here, stalls out, strengthens, intensifies, and then starts to head back east, and then northeast, and then it intensifies into a 951 millibar low, which would be at least a Category 4 hurricane, and then goes on and makes a landfall along the west coast of Florida about 9 days from now. Okay, not this weekend, but next weekend. Okay, catastrophic run that we absolutely do not want to happen. And look, there's another system down here too. And this could be sneaky and take a name before this does. So let's not go down the wormhole here of names here. But this is the GFS run from the lunchtime model, probably pretty much a 12Z model run. Okay, and then this eventually gets off the coast of the southeast, brings impacts to the Carolinas, Georgia, etc. Now let's look at the latest run. I want you to look at how different this is. Okay, remember on this run of the GFS, it took all the way till next Saturday evening, not this Saturday evening, next Saturday evening, for it to actually hit land, which in this case is Florida. Okay, now watch this run of the GFS. Same thing, we'll start off this Sunday, the 22nd. Okay, we take it into Tuesday. We take it into Wednesday, just this huge broad area of moisture right here. And check this out. It has a major hurricane off the coast of Mexico. If you look at the run from earlier this afternoon, it doesn't have anything but a 1,004 millibar low. That's how flip-floppy these model runs are right now. Okay, but like I said, everything is pointing to something getting going in the Gulf of Mexico. Okay, we get this in the Thursday morning. Quickly develops a tropical system, much quicker. And I would say it doesn't develop it any more quicker. It develops it and gets forward motion to it a lot faster. Therefore, it gets picked up and gets slung towards Florida. So we have a tropical storm forming around next Thursday morning in the eastern Gulf of Mexico. And then we take it all the way to about next Thursday. Okay, next Thursday evening, this makes landfall as like a strong tropical storm, Category 1 hurricane. So actually the GFS makes landfall in the same, pretty much the same spot as the GFS from 12Z. But the 18Z, the current run, has it happening what? Let's see. It happens a good 2 days earlier and much, much weaker. Category 1 hurricane here. This is like a Category 4 or 5 hurricane. So that's a huge difference. But I will tell you, the location it hits is the same. And then it goes over Florida and then goes on off the coast of the southeast and then heads on out and might impact the northeast, but there's no point in zooming into that. So pretty wild stuff. So I just kind of want to compare both GFS runs and how different they are. You know, where they head isn't a big difference. The strength in that case is a big difference. Now check out the Euro. All right, same thing. Euro, we're getting, let's take it all the way to Tuesday morning. All right, just a blob of green, tropical moisture down here. We get into Wednesday morning. We're getting a little bit of organization, but still just a broad area of tropical moisture. We're getting into Thursday. We're getting some organization in the Bay of Campeche. So the energy is all the way over here on the Euro. Okay, instead of over here like on the GFS. Huge difference. And the Euro has been consistently further west. Okay, and we keep this going. And finally, the Euro, about 7.5 days from now, develops a tropical system in the Bay of Campeche and begins to lift it north very slowly. And 10 days from now has a strengthening tropical storm somewhere in the Gulf of Mexico, but way far west. You compare this with the GFS, that's a huge difference, right? This is the GFS on this, obviously not this Thursday evening because that's right now, but next Thursday evening, basically a week from today, has a tropical storm, Category 1 hurricane making landfall in Florida. The Euro next Thursday has just a big area of moisture way over here in the western Gulf of Mexico in the Bay of Campeche. That's a huge difference, right? Now, what about the Euro AI model, which, by the way, is kind of a new model on the block, and it has some pretty good verification scores. So we go over this. We get all the way out to next Thursday. We have this low pressure moving off the Yucatan Peninsula. It kind of gets in the same spot as the 12Z GFS gets. Has it gradually strengthening, has a 994 tropical storm next Thursday morning. It's starting to cruise across right in the middle. It's going right down the middle of the Gulf of Mexico, right in the central Gulf here. And 984 Category 1 hurricane moving north, and it makes landfall as about a Category 1, maybe low-end Category 2 hurricane right into the central Gulf coastline about 7 to 8 days from now. Okay, so it's literally right in between the GFS, the latest GFS, and the Euro. Okay, so the GFS is over here. All right, the Euro is over here somewhat, and then the Euro AI model is like right in the middle, kind of goes splits the gap right between both. So very interesting stuff here. Okay, now the icon model, and we'll just fast forward this. When I get in this emotion, you can quite literally see the spin down there. It's pretty wild stuff. The icon model kind of follows the Euro. Further west, it's stronger than the Euro. So 1 week from today, the icon is way already in the western sections of the western, on the western side of the Gulf of Mexico, still kind of extending south into areas of the Bay of Campeche, but it has about a strong Category 1, well, I would say about a Category 1 hurricane. Okay, way over here. Remember, GFS is way over here. So big difference here. What about the Canadian model? Canadian model gets this together pretty quick. Already have a tropical storm midway next week. We have a hurricane next Thursday morning, about 6.5 days from now. Category 1 hurricane that strengthens into about a Category 2 and then makes landfall into the Louisiana coastline about 8 to 9 days from now, like next Friday or Saturday. Very broad, very large hurricane. And I could see this being the case because of the huge moist field that's going to be situated with this. So there's definitely some big differences here. But from all that I just showed you, what is the common theme in all of that? Something does develop and get into the Gulf of Mexico. And what do we know about the Gulf of Mexico? It's got to make landfall somewhere. It ain't about to, like I said, just hit it in reverse and then head back out into the Atlantic Ocean. So if we look at the GEFS ensemble from this afternoon, okay, we'll start this off. This is from Monday morning. All right, all these members, the GEFS ensemble makes up 21 members. So if 21 members develop a tropical system, then you'll see all the L's on your screen. If only 14, then you'll see 14 on your screen. But watch as this continues to move. So at this point, we're about all the way out to about next Wednesday. Okay, some members are just getting kind of trapped or just forming down here in the Western Caribbean. Some of them are just splitting the gap between Cuba and the Yucatan Peninsula. You got some members over here going over the Yucatan Peninsula into the Bay of Campeche, and you got some already getting into the Gulf of Mexico and heading north and strengthening. And you extend this, let's go all the way out to, what is this, about a week from today. Same thing, guys. I mean, some of this model guidance is just showing this low pressure is just like, it's showing a scenario where the low pressure is just getting out of the Western Caribbean. Like you see this right here. See how they're clustering right into here? These are some of the slower scenarios, but you got a couple stragglers that are getting way out in the Gulf already, and then you got some that's already made a landfall and are heading, across the southeast. And I would say if you live in the southeast or along the entire eastern seaboard, you got to pay attention to this too. Not because this is going to do something like this and then make a landfall way over here, but because, wherever this comes inland, this is going to bring impacts, right? But pretty wild stuff. There's a massive spread with this. And if you look at the European ensemble guidance, which takes us about a week out, it really favors more of a westerly track here. And if we just go on and extend this out, let's just go 10 days out on the European ensemble here, which makes up 51 members, by the way. A lot of this gets kind of trapped into the Bay of Campeche. And I can tell you on the European ensemble, and I'm not really buying it. I'm really not. It shows a lot of members that don't even form. But the ones that do form to kind of escape up here are pretty strong. 994. I mean, gosh, this one's like a 928. I mean, that's ridiculous. So that's all the model guidance here that we have. Now let's talk about the environmental background that does favor an intensifying tropical cyclone. I mean, we'll go over this really quick. Sea surface temperatures, go on and check that off the box. This is in Celsius, 30, 31, 32 degrees Celsius. That's equivalent to about the mid to upper 80s, guys. Bathtub waters is rocket fuel here. I mean, look at how warm this area is right here. And this is basically where the origins of our system is going to form, okay? Right over like sea surface temperatures in the mid to upper 80s, okay? And then it's plenty warm in the Gulf of Mexico and off the coast of the southeast here. So rocket fuel, it's very warm. It's been warm for months now, and that's not going to change over the next couple months. So check that off the box for an ingredient that supports an intensifying tropical system. So let's buckle up here and try to explain this to you guys, the audience, where you all can understand, especially for any of our new viewers. So this is the part where we really nerd out with you guys. So what you're seeing here is the upper wind pattern. All right, these are winds in like 200 millibars, which is about 35 to 40,000 feet up in the air. Okay, so you see these areas of blue, and especially the green, yellow, and orange up here. This is where you have stronger winds aloft in the upper upper levels of the atmosphere. Okay, where you see white, that's where you have a really weak flow aloft. Okay, you have a flow moving in a direction, obviously, but it's very weak. So the more you see white areas associated with a low pressure, more than likely the amount of you have very low shear for this tropical systems. And if you don't know anything about shear, let's just put it this way. Tropical systems don't like shear. High shear disrupts the structure of a tropical system, allows for dry air to get in. They like low shear environments. So what we're here to talk about is how this is going to have a low shear environment. So we start this off for this coming Tuesday. We start to get, and we're backing it up. I don't know why I'm doing that. We start to get into next Wednesday morning. So we have a low pressure developing here in the Western Caribbean. We're getting divergence aloft. So in the low to mid levels of the atmosphere, these tropical systems, they spin cyclonically. So just like this. Okay, so this is, it has a very broad spin, cyclonic spin to this too. In the upper levels of the atmosphere, air is being pushed out. If you look very closely, you see these little lines with little arrowheads or arrows kind of pointing in the direction that the airflow is going. Well, check this out. I'm going to draw along it and check out how this flow kind of goes like this. Down here, you can barely see it, but it's getting pushed out like this. It's getting pushed out like that, and really getting pushed out like this. So this has one heck of an outflow channel. So basically, as air is rising in this system because it's trying to develop shower and storm activity because of the lower pressure, the air that rises gets dispersed away. You see how the arrows are pointing away from the actual low pressure? See how this one's pointing away? So as soon as that air gets pushed away in the upper levels of the atmosphere, it's pushing away from the system. So that air gets dispersed outward, whether it's an anticyclonic flow or whether it's just directly away from the system, air is being pushed away. That allows for more air to rise quickly up through. That air gets pushed away, allows for more air to rise. What we know about rising air is we need rising air for shower and storm development. Shower and storm development allows for a moist environment for these tropical systems. A moist environment allows for this system to intensify, therefore improve its structure, vice versa, and then could eventually undergo a period of rapid intensification. So it's a process, right? So sometimes we call this what we call a ULAC, an upper level anticyclone. That's quite literally when these low pressures are situated directly under a flow that is anticyclonically in the upper levels of the atmosphere, which supports rising air. So we keep this going here, and it gets kind of weird. And this is not the best example of this right into here. A better example of this is if we flip this back to the 12Z run right here. Okay, and it's not because Mitch is trying to show you the worst model runs with the worst case scenarios. It's because I want to show you better examples of this. So right here, the system stalls out, and I'm going to talk about why it stalls out here in a second. There is no shear. This system is just pretty much in this huge, broad flow aloft that supports air being dispersed away from the center of the storm. Okay, so here it is. It's spinning like this. And this is the wacky 12Z run. Air is being pushed out right here, right into here. Air is being pushed right here. But in general, you do have some air being pushed up against the storm, which would create a little bit of shear. But here's the key, guys, is there is hardly no flow aloft in this area. I'm just going to circle this area on this particular run. There's no trough digging down or no ridge or really anything affecting the flow of this system. Nothing. Okay, so this system is basically chilling in an environment, and you can see all the white around it. The little bit of blue you see around it is the system creating its own cyclonic flow aloft. So don't focus on that. But in general, the reason this thing intensifies on this particular run of the GFS, as you can tell, you back it up a little bit, 993, 983, 978, then it intensifies to a 962, and it deepens all the way to like a 950 millibar low pressure here, is because there's hardly no flow aloft, though, so there's no air hitting the system, disrupting the structure of the system. So even though there's not really air being pushed out away from the system, there's no air at all. So this thing is just literally just sitting there breathing and ventilating very well. So hope that makes sense. So what I'm trying to say is, once this system gets going, it should have one heck of an upper level wind field to support strengthening with this system. And you can see it really happen here. I don't know what happened on my screen. I'm going to just put this right here, okay? You can see this really happen. Let's back this up to the 12Z. We're going to start this off already from Monday evening. So this coming Monday, already a huge area of moist air, okay? The brown area is dry air. Huge area of moist air because of this Central American gyrum, this huge broad area of low pressure. And watch it as it just cruises into the Gulf of Mexico right here. There is no dry air really affecting the system. It tries to get in right here. Remember on this map how I was just drawing some arrows pointing to it? This is a good example. A little bit of shear tries to hit the system on the west side. Dry air gets really close because of that shear, but this thing is so situated in such a moist environment right along the center that dry air doesn't even have a chance to get in, and there's so much divergence aloft on the other sides of this system, especially right here. Such a solid moist channel right in here, it really is, that this system doesn't really get bothered. And you keep this going and just look at this thing. I mean, it's crazy. Let's hope nothing like this happens, but this is, you know, the crazy run of the GFS, which we really hope and pray nothing like this happens. But you can see dry air trying to get sucked into the system. But like I said, the system is so saturated, so situated in such a moist environment and cocooned itself and protected because of such a strong hurricane that dry air is not getting wrapped into the system. Okay, and eventually it does. Right here, here's a good example of the dry air getting all the way to the low pressure. But down here, it cocoons itself in such a moist environment because of that upper flow aloft in the beginnings of this system, really. I think that once this gets in the Gulf of Mexico, I would say this, guys, if this thing strengthens in the Caribbean and the southern Gulf of Mexico, then it's going to have a potential to hit one of those higher end scenarios. If it doesn't, then dry air can mess with this system enough to where it can never get going, which we hope for. Now, we're talking about steering currents. I want to show you this first. I'm going to draw on this a little bit. So, flow around low pressure, which, by the way, is in the blue, goes just like this. Okay, just like our tropical system. Flow around high pressure is going to go like this. So, flow around this high pressure is quite literally going like this in the mid to upper levels of the atmosphere. And there's that low pressure right here. Flow is going around this low pressure right into here. So I want you guys to keep that in mind as we're about to go down to the Caribbean. Okay? So keep that in mind. Keep it in your head. Flow around high pressure, it goes anticyclonically. Flow around low pressure is cyclonically. Don't want to mess up my cyclonic flows up there. So let's get this all off your screen and let's keep going here. So we go down here. And we start this off for Wednesday. If you squint your eyes, you put on your bifocals, you'll see a little, get off my screen here. You'll see a little blue dot right here. That is our low pressure starting to consolidate. Okay, so it's forming. Here's a low pressure developing. I want you to note right off the dot, there's a bunch of white surrounding this system. This tells me there's no ridging and there's no troughing. You can call these areas of blue multiple things. A trough of low pressure, an upper trough, whatever you want to call it, it's low pressure. You can call the area like an orange, a salmon color, a ridge of high pressure, ridging, high pressure, whatever you want to call it. Flow around it works the same regardless of terminology. Okay, so we get this off your screen and we keep going. Now watch what happens. Low pressure, and let's keep it on the 18Z run. Low pressure is able to escape north and fill this new trough on the latest GFS. Okay, so we know, one thing I want to know before we get too far ahead of myself here. A stronger system is always going to want to gain latitude. It wants to go north. Okay, and if there's no flow pulling this one way or the other, then it's just going to go north. Sometimes it'll drift around, especially if it's a weaker system, and be influenced by light ridging or light troughing. But in this case, this system feels a pretty stout weakness right here, generated by this upper trough diving down on the latest GFS. Okay, so with this happening, flow going like this, all right, and then flow going like this around this trough, okay, there's a weakness right here for our system to kind of head north and then get kind of pulled by this flow going like this around this low pressure diving down into the eastern U.S. So that's why the latest GFS immediately pulls this up. Doesn't give it much time to strengthen because it feels the pull around this trough that's creating this weakness, and it just heads on and goes on and makes a landfall into Florida as a weaker system. This is a Category 1 hurricane. Okay, now why is the GFS run prior to this so dramatic? Well, it's because this system moves in, it stays a little bit further south, okay, drifts a little bit further to the west. It misses initially the pulling mechanism of this trough. So flow's going just like this, and we don't even really have to talk about ridging because this ridging and this flow around the ridge is just too far over here to really mess with the path or tug on this storm at all. So there's our huge tropical system down here on this run, the GFS. Well, it's so far down here that it's not really feeling. There's a weakness up here, but it's just kind of lost in really stagnant currents in the upper levels of the atmosphere. Not getting pulled one way or the other, but eventually it starts to fill this trough right here. And I think just the fact that this strengthens and starts to head north because it strengthens, you see how the blue connects here, low pressure connects with low pressure. So this area low pressure quite literally yanks on this system towards Florida. You see how that happens here? You see the blue up there in the southeast mid-Atlantic? See how it yanks on our low pressure and then it tugs it towards Florida. Okay? And it makes sense because the flow around this trough is going just like that. Okay? So it feels that and heads towards that yank this way. Okay? This is going to change a lot. You know, if you sit here and you kind of mess with the European and why it kind of does what it does, Well, it just looks a lot different. It looks kind of weird. It keeps this system weak. It has this large ridge. This is the massive difference with this on the Euro than on the GFS. I mean, we can look at the GFS. Let's see. GFS, let's go all the way out to Wednesday morning. Okay. Wednesday morning has some light ridging on the GFS. And this is the 12Z. Let's actually go to the 18Z. It doesn't even have it on this one. So Wednesday morning on the GFS, it has this trough over the eastern U.S. Okay? Wednesday morning on the Euro has this ridge over the southern U.S. and the Gulf of Mexico. So therefore, flow around this ridge is going to go just like this. So our system, which is kind of right into here, which is weak, is easily going to get pushed into the Bay of Campeche and the western Gulf of Mexico over the Yucatan Peninsula. It's because the flow around that ridge is going like that. But, like I said, you kind of get this off your screen. You look at the GFS. That's not there. That ridge is not there. So that's why, it kind of gets into the Bay of Campeche, chills here for a while because, there's no flow around it. You see all the white around it? Eventually it strengthens enough where it kind of starts to go north, but it takes a lot longer. On the Euro, it's one heck of a process. So that's all I got, guys. Hope you got a lot of good information from that. God bless all y'all. Y'all have a wonderful night, and I'll talk to you again in the morning. God bless.